Hi, I'm Dieter and I welcome you to this live demo recording of our electron-beam welding machines at the Focus company in Kesselbach, Germany. In the next 20 minutes we will show you a range of our welding products, namely the MEBW-60 in 3 different chamber sizes, 135, 95 and a compact 8-liter version. We will talk about different options to handle a workpiece, for example rotation or CNC manipulation stage combined with a gun shift on top of the chamber. One of our specialties is that the welding operation happens under vacuum, so we will demonstrate how fast this is accomplished. The ultra-fine electron beam can precisely be manipulated with deflection to achieve ultimate precision on workpieces in the micrometer range. We will demonstrate this on real workpieces and check the welding in an optical microscope afterwards. I hope you will enjoy this exciting insight in our welding technology, and I wish you a lot of fun with this video.
Today we're here to show you the, our production type machine, which is the L135. What you see here is basically the chamber. We do have the electron gun is up here. There's the optical camera inside, looking inside. We do have the SEM detection system as you know it. We do have a 6-fold rotator mounted here, which is this piece. It's all flange mounted. It has 6 revolvers or 6 chucks which can revolve and can be indexed. Each of them can rotate individually. And yeah, we're just opening the chamber in order to show you how it looks inside. So this was vented from vacuum to ambient. What you see here is this 6-fold rotator. You see this individual 3-jaw jugs. There are 6 of, and the clamping diameter is about 100 millimeter for those. And I think the length can be of the workpieces up to 200, 250 millimeters. You can also see there is a possibility to take out the bottom of this chamber. So this workpiece holder can be slided by 90 degrees and be mounted from the bottom. So this entire rotator can be mounted from the bottom, and the electron beam would then see it from top instead of from the side. Instead of 6, you could have 1 large single piece rotator, which is shown to the left here. So this item here has a clamping diameter of up to 200. So if you had larger workpieces, you take off this 6-fold rotator and you mount this single-fold 3-jaw jug, clamping diameter 200, and the length can be about 300, 350. There is a tailstock, a life center, which you can operate in order to have larger workpieces supported. What can also be done with this type of machine, you're able, when you take out this 6-fold rotator, you're able to put in an XY stage, a CNC controlled XY stage, and we have one here just on our table. So you basically take the entire unit out and replace it with a 6-fold or vice versa. This plate is about 230 by 250 millimeter, and the traveling distance is plus minus 75 in each direction. There is a possibility to mount a small rotary unit in case you need to have items rotated while they are positioned on this XY stage. We'll show you on the other machine where one of these tables is mounted, and we will use this for demonstrating the beam deflection. So changing this workpiece holder would be something which can be done by 1 person. 2 is helpful in order to support, because the items are not super heavy, but you better do it with 2 persons. Let's go to the computer monitors here. We have basically 4 screens. We have 1 control panel here, which is dedicated to beam control. This controls everything on the electron beam generator, high voltage, current, deflection, centering, everything which is related to what the beam does. we do have a CNC control software which is called Mach 4, which controls the mechanical workpieces like the XY stage, the rotator, and all that kind of things. We have two screens here on the left-hand side. It's an optical image which comes from the camera, which is mounted next to the gun, and we have secondary electron imaging here, which is only, of course, possible when the electron beam is on, which requires vacuum to be there. I suggest we'll show you the workpiece sequence which Thomas has programmed in ambient with the open chamber, so you can see the mechanical items which are swapped around, which rotate and things like that. Later we pump it down and do a real welding. The welding, the workpiece manipulation and everything is a G-code based program, as all CNCs. We have 6 synchronous axes, and there is a lot of related things which are not synchronous, which are M codes, which are macros, and these macros are all interfacing between the CNC control and the beam control software. This is 80 seconds for this type of chamber. We're gonna see it in a couple of minutes when we are pumping the whole beast down. What you see right now is a rotation gun shift. You can see it in the optical image. Martin just focuses here on the workpieces rotating. Yeah, you can see it in the optical camera rotating. The alignment is done. You are using the SEM control as primary image, and the optical is just set up to overlap the SEM imaging. So the crosshair and everything can be adjusted that everything is, let's say, coincident or in line. This little button you can tilt. You can see now on the optical image, you can see I'm shifting forward and backward. So you're able to adjust the zero axis, let's say, of the optical camera, right? It's a mechanical thing. It's just tilting a prism to the right position. So adjustment of the entire units manually is done through a remote control panel, as Thomas just does it. You have this yellow colored item which does the CNC motion axis. So you can jog by using the dial button there and basically manipulate in different increments, fine adjustment, coarse adjustment. So you're able to travel the entire axis manually, or if you're handing over to the CNC control, CNC takes over and takes control. Just to show you the time we need to pump down the machine, Thomas just puts his mobile with the stopwatch in order to show you. What you see here is the pressure gauges here on the bottom. We're at atmosphere, and the electron beam generator, because it's valved off, is at a pressure of 5.45 10 to the minus 6. Now Thomas starts the pump down button. It's a bit noisy because this is a heavy pump. Takes a little bit before the gauge just reacts, but we're already at 100 millibar. We're using a big bypass pump in order to pump down and fast evacuate the main chamber. And when we reach a certain level in the range of the 10 to the minus 1, we are swapping over to the turbo pump, which is attached to the backside. You will see in a couple of seconds when we're at switchover pressure, which is 3 or 4 times 10 to the minus 1. Yep. So you're now, you heard the valve opened and the bypass pump has been switched off. We are now reaching the pressure for welding, which is, the threshold is set to 4 times 10 to the minus 4. So now you're ready to go for the welding process. So we tested this machine intensively. It's spec'd to go below 1 to the minus 5, below 15 minutes. This machine does between 7 and 8 or something like that, minutes. So now we can basically run the entire process once more under SEM control. before we do the final weld. So the electron beam generator works with a 60 kV and up to 33 milliamps, which gives you a total of 2 kilowatt. Right now, the SEM picture is showing up on the uppermost left image. Let's run the CNC program once more. So you can see the motions now under SEM control. So what we are doing when we are welding, we are switching off the SEM images because the beam needs to be controlled for the welding process and not for the imaging process. When we're scanning, right now I think it's 180 microamps, 0.12 or 0.2 milliamps. We can go down pretty low with the beam current, down to in the range of 20, 30 microns. Welding depends on whatever you need to do with your materials, but it can go to very low powers, and you can go with very minor step increase of 10 microns. The optical camera can be used during welding. However, there's a protection window inside, right? We have a shutter. It's now shut off in order to protect the window. The window protects the optics, but the shutter protects the sacrificial glass. The glass is an ITO-coated electrically conductive piece of glass, which needs to be replaced from time to time. It protects the entire prism, the optics, which is directing the picture to the camera. There's a beam guide tube where we have not exact parallel beam incidence. In the optical image, you can see the welded picture. So beam current is 2.5 milliamps. Yeah, basically this is just going through all these weld seams, which we had previously shown in the open vented chamber. So what you see here on the top left corner, on the top left image window on the screen, is a live video which is not digitally recorded. It's like a TV style picture. If you want to do images through the software, you swap over to the beam control software and you can take an image from there. What Thomas right now does is he is showing you the image taken with the beam control software. You're now seeing the acquisition of the data through the beam control software, which gives you a higher resolution, a higher image quality, because it's going more slower. But if you need to do something for documentation, for measurement, things like that, you usually go for the higher quality images. While for real-time control, you're using the live image, right? Because you want to see how things change in reality very fast. It has been acquired by going with the DAC card, with the integrated, let's say, digital scanning generator, while the left live image is taken from, let's say, from a TV-style deflection system, old-style cathode ray tube thing, which gives you the 25 images per second, right? While the right-hand side changes the scanning generator to a digital one, which produces the higher quality, higher resolution images. So we are now having opened the chamber again. So Thomas now takes out the beam guide tube, and the beam guide tube has the protective cover, and we'll going to show how we can change that very quickly. So right now I think we need to get the E-gun more to the center in order to get access with the Allen key to the two screws we are interested in. The electron beam generator, as you see it on top, there is a tube inside protecting the beam, and this holds the shutter, and this holds the sacrificial glass, and it also protects the entire beam from magnetic interaction with everything which is surrounding, right? Basically, the two screws are just opened by Thomas. So what we see here, this is the glass disc, right? This one. And here we have the shutter, right? This is the shutter blade opening. It's externally operated by a pin, right? So this will open and make the shutter open and close. So when the window is coated after some state, you just take this one and rotate it further to the next position. Depending on how heavy this is coated, you could try to wipe it off, or basically this is the important thing is it's electrically coated, it's coated in order to make this non-charge up. Otherwise the beam would interfere. What we have also in here, in this machine, just for the demo, is a plate on the tailstock in order to show you the beam deflection, let's say, in a bit of a more rugged way. We're going to show you in real on the other machine, right? But this is something we can show here with this type of machine. So on the machine itself, you have seen also here 2 remote control panels. We have this remote control panel here. That basically is again a beam control thing. So everything which you can do with the software, you can do manually. Pump down, machine operation, beam current. You won't be able to do super fancy things with that kind of thing, but you're able to run the, let's say, the basics, right? You can do like, you know, if you want to set up the beam current, the imaging current, and all these things are done through that remote control panel. Similar is this for the CNC, for the machine control, for the workpiece manipulation. It has the same functionality. So we are having 2 remote ones, which allow you to do the traditional standard operating workpiece and beam manipulation things. So now the Thomas has now just put that little plate right in the beam, under the beam, in order to do a little demo on that. Okay, we're pumping down again. While pumping down, we can have a look on the, let's say, on the infrastructure of the machine. What you see here is the rack. The machine comes with a rack. The rack can be placed depending on the radius here of the high voltage cable, which is on top. So you can put the rack here, but you could also place it here, or if you really wanted to, on that side or to the other side. So it's a question of, let's say the radius around the gun related from the, which is in relation to the electron-beam generator. Here, all electronics is in. Infrastructure is supplied through here from the side. There is compressed air, there is cooling water, and there is power. There is not much more than this. It's all here, except for the power. The power is going on the rack. This is compressed air, this is cooling water, and everything else is distributed from here. So the power requirement is really moderate. Is not taking too much of power. Most is related to the pumps and to the workpiece manipulators and things like that. They don't take real much power. The cooling water is used for the turbo pumps and for the roughing pump. This big roughing pump requires, it's an oil-free roughing pump in this case. It requires water cooling. So the turbo pump here is a 2000 liter turbo pump. So we have one big turbo pump pumping the chamber, and we have a smaller turbo pump backing the electron beam generator here. There is one joint roughing pump for both turbos, and the big pump we do have just bypasses the, or is a bypass pump for the main chamber in order to get out the vacuum fast and, or to create the vacuum pretty fast. We try to see if we can have a view inside the chamber, so you may see the beam eventually. As we use the SEM control regularly, we're used to that, and we like that as a similar or even better feature. Here we are, and you can see the SEM image showing the circles again. So what we see here is, it's called the L95 machine. It's a medium-sized machine. For us, it's also a large machine. It has the same type of E-gun. It's the original design. The one which you see on the other machine is the, let's say, version 2. It's been improved in various mechanics. From the performance, it's identical, so there is no change in the performance. This machine has the capability of only using XY stage and a small rotary table. We will see that later. And the pumping system is a little bit smaller, but apart from that, the machine is similar in handling, in operation, and there is no optical camera with that type of machine. So what we do have here is we have a, let me see, we have a special item here. You can see inside here maybe that are 5 pins, electric pins, which are part of a ceramics, which is Covar surround or stainless steel surrounded, which needs to be welded into this housing here. And this is basically the ceramic inlay is something Thomas needs to weld anyway for a customer. So we said, let's do this and use beam deflection in order to do this, right? This welding. So the dimension of this electrical feed-through, I'd say the length maybe 10 to 15 millimeters. The machine is pumped, is ready for running. So you can see on the screen here, the live image. We have covered the electrical feed-through, of course, in order to avoid evaporation. So there's a little cap on top. And what Thomas now does is he is using the beam deflection control software, which is on the right monitor. First takes a picture. Then we need to adjust the welding contour with the SEM image we have taken. So the overlay needs to match. And then when this is confirmed, we can start the welding process. The welding path here is the red line, which the beam will simply follow, right? So you're basically sizing it, then you take an image, you overlay it, you may eventually refit it, and then, yeah, that's it. So, of course, we have done this before. Thomas will start the welding process. We have now done a couple of those welds for this customer we have here, which he requested, this job shop thing. And yeah, we will be able to show you this under the under the optical microscope. Fertig. That's it. That's done. So we're venting the machine, take the part out, and while we put it under the microscope, we can have a quick view inside the chamber to see how the workpiece manipulation looks like on that machine. So you can see here the XY stage. You can position the rotator this way, facing up, vertical, or horizontal. So you can do radial welds. In this case, you can do axial welds, right? Either by beam deflection or by rotating the piece. A rotary unit is an optional item. You can either leave it on or take it off. So you only unplug that little cable which you can see in the corner, which gives the motor the power. That's all you need to do. So you take an Allen key and fix it to the T-nut plate, and or you fix your own workpiece holders to that plate. So what we have is 3 flanges on this machine, so you'll be able to put it here, here, or to the right-hand side. Just physical remounting. Of course, it's not so convenient. I think most people leave it just in the center as it is. That is the welding of this electrical feed-through here. So you have the possibility to do a ramp in, ramp out with a power. So here is something tiny. If you look at that, and if you're into electronics, microwave design, it's a platinum spiral which is welded to a, let's say to a holder. It's 0.2 millimeters. It's a waveguide tube. That is, we consider this a small machine. It's 8 liters, and that pump down time is in the range between 30 and 60 seconds. But this has 2-dimensional workpiece manipulation capabilities only. But it has, apart from that, it has the same electron gun, the same CNC control, and all that kind of things are similar than the bigger machines. This is only air-cooled. There is a version which has only power, no compressed air, no water cooling. This goes up to the limit of a single phase, so 3.5, 16 amps. This is mainly related to the high voltage supply. If that runs at full power and the pump runs and everything runs, we're about approaching the limit of the single phase. The other 2 machines are working with 3-phase 400 volts. Thanks to our guys.
You're welcome. Thank you. Bye.